Hello everyone, my name is Oluwatobi Ademosu. I am a graduate of Electrical and Electronics Engineering from the University of Ibadan, Oyo State, Nigeria. I am presenting my final project for the Emertxe IoT Internship 2026 today, and the project is Smart Factory IoT Monitoring System. I am focusing on IoT based industrial monitoring and control. I would like to explain some of the things I've learned during the internship. Now, the Internet of Things, also known as IoT, refers to a network of physical devices embedded with sensors, softwares, and connectivity that allows them to collect and exchange data over the internet without human intervention. The cycle of IoT involves things, perceiving the world, connecting via networks, collecting data in the cloud, and acting through automation. This implies that automation is the bedrock of this thing, which makes it possible. Now, IoT is transforming multiple industries. The key use cases include the smart manufacturing for predictive maintenance, smart homes for automated lighting, healthcare for patient monitoring, and the smart transport for fleet tracking, and agriculture for precision irrigation. During the internship, I learned about IoT, and the project we implemented follows a four-layer horizon architecture. The perception layer includes the Arduino Uno and sensors like GHC22 and LM35, which senses temperature. The network layer uses MQTT protocol over an Ethernet shield, W500 shield. All right. So the processing layer is handled by ThingsBoard and its rule engine. And finally, the application layer consists of the web dashboard and the alarm notifications, which alerts the user based on the rules that was given to it. Modern industrial facilities face significant challenges. One of them is lack of real-time visibility into environmental factors, delayed incident responses because threshold breaches go unnoticed, and inability to remotely control equipment during emergencies, and the chief of them all is the costly reactive maintenance due to a lack of trend data, and that forms the problem statement. To solve these issues, I learned and developed a distributed multi-node IoT system using Arduino Uno nodes connected via Ethernet shield to publish data over MQTT. The ThingsBoard platform was also used for real-time monitoring, automated alerting, and remote RPC control. Now, for the nodes, the system consists of just two nodes. Node 1 monitors the production line. It tracks the shear temperature, the machine temperature via LM35 temperature sensor. It also checks the vibration using a potentiometer. Then node 2 monitors the warehouse using the DHT22 and LDR for light sensing. It also uses a PIR sensor for motion detection. Now, for the function and the simulator requirement, functionally, the system collects real-time sensor data and publish the MQTT telemetry using JSON payloads every 5 seconds. Because this is a simulated environment, I use PICSimLab to replace physical hardware because of the cost involved in getting physical hardware and the possibility of damaging some of the components. I use the virtual sensors, and the Ethernet shield was also simulated. Now, for the communication, the device use MQTT over TCP and IP protocol. It connects to the ThingsBoard broker on port 1083. The payload is formatted in JSON format with a publish rate of exactly 5 seconds per node. Now, I configured the system based on what I learned using the specific rule chain. For instance, if the temperature exceeds 35 degrees C, a critical alarm is triggered. It turns red light on, right? Um, and it also send notification. A vibration above 700 will trigger a warning with a yellow LED, and humidity above 80% will trigger dashboard alert. In conclusion, this was successful, and I would like to show you the live demo now. So here is the node 1 and the components connected to it, the LM35 and every other component I mentioned earlier. Now, notice that this is the analog valve, and any changes I make to the simulated hardware will reflect on the dashboard. So first, I would like to adjust the value of the temperature sensor. So there are three screens I try to connect together. First is the Arduino, the connection panel where all the sensors are, and then the dashboard. So I'm trying to choose to switch to node 1 where the the dashboard is. So now I'm trying to lower this the value of this hardware. So I notice the changes in real time. So this is just the simulation of the first node, and in between the dashboard and the other part is just the terminal that shows the data that is sent to the dashboard. So also here you can see the communication that it is bidirectional. So I can communicate to this device from the dashboard, and here is the relay control which turns on this LED, right? So it shows a bidirectional communication between the hardware and then the dashboard. So also this will update in real time. That is the machine temperature over there controlled by LM35. Also, there are other charts. This is the machine temperature, like I said earlier, and this is the air temperature and machine temperature, the trend over time is seen over there, and the MQTT telemetry in the last chart. The vibration data also is here, as well as every other data that we're asked to visualize or to import in the whole design. Now here is the node 2. This is node 2, and it contains the charts, the gauge, and the cards according to the design requirement. I changed some value and did not use the custom widget because after uploading it, it couldn't really display on the dashboard. So I had to use the available ones. As I change the value or alter the value of the hardware, it shows on the dashboard. Changes the temperature and the humidity updates on the dashboard, as you can see. So also based on the design, when the temperature or the value of all the sensors goes above a certain threshold, then it should trigger alarm or trigger the red. So basically, when the temperature or when the humidity is above 80%, it should turn on the red LED, which is what we are seeing over here. Not that anything bad is really happening, but it was because of the LDR or other sensors connected. So this is the virtual terminal showing the data that is uploaded or sent to ThingsBoard, and this is the Arduino Uno that I used. Now I try to start it all over again so as to show the whole process involved in all these things. Then finally, we can check the third dashboard. That is the overview. This contains data from the production line and the warehouse, including the charts to visualize of the data in the two different nodes. That's node one and node two over time. Then it also contains the data of the alarm from the design. All right, according to the design, if the alarm goes above a certain threshold, it should indicate on this overview dashboard, which is what we are seeing here. I also designed the alarm rule based on what I was taught. I implemented the alarm rule for the different nodes. In conclusion, this project shows how IoT can provide real-time visibility, automated safety response, and remote control to solve modern industrial challenges. I want to appreciate the team at Emertxe for their guidance during this internship. My name is Oluwatobi Ademosu, and I'm indeed grateful for this opportunity. Thank you.